Right now, there are places on Earth where millions of people live directly above active natural systems. Systems that build pressure for years and release it in minutes. Earthquakes, volcanic eruptions, flooding, extreme storms. These are not rare events, they are part of how this planet works. So the question is your location one of them? These are not random disasters. They are predictable natural systems driven by physics. Tectonic plates move constantly beneath the surface. Oceans store heat that powers storms. And climate systems shift water and air across the planet. Some changes happen slowly over centuries, others happen suddenly. But all of them are all active right now, and millions of people live directly within their range of influence. Remain in the video to find out. Vesuvius. Mount Vesuvius is one of the most studied volcanoes on Earth. Located near Naples in Italy, it is globally known for its eruption in 79 AD, which destroyed the Roman city of Pompeii in a matter of hours. That eruption produced massive pyroclastic flows, extremely hot, fast-moving clouds of ash, gas, and volcanic debris that buried entire settlements almost instantly. Today, Vesuvius is still classified as an active volcano. Despite its long periods of inactivity, it remains under constant scientific monitoring. Sensors track seismic activity, gas emissions, and ground deformation to detect early signs of magma movement beneath the surface. What makes Vesuvius particularly significant is not just its geological behavior, but its location. More than 3 million people live in the surrounding metropolitan area of Naples. This creates one of the highest population exposures to volcanic risk in Europe. Volcanic systems like Vesuvius do not behave like predictable machines. They can remain quiet for decades or even centuries before reactivating. The main challenge is that pressure can build silently underground without obvious surface warning signs until a sudden eruption occurs. Netherlands. The Netherlands presents a fundamentally different type of environmental risk. Unlike volcanic or seismic regions, the threat here comes from the relationship between land and water. Large portions of the country lie at or below sea level, meaning that without human intervention, these areas would naturally be submerged. To make habitation possible, the Netherlands has developed one of the most advanced water management systems in the world. This includes an extensive network of dams, pumping stations, and storm surge barriers, collectively known as the Delta Works. These systems operate continuously. They regulate water levels, control river flow, and protect coastal regions from North Sea storm surges. In many areas, land is not naturally stable terrain, but rather reclaimed land known as polders, which require constant drainage. The key characteristic of this system is that it does not eliminate risk, it manages it. As sea levels rise due to climate change and storms potentially increase in intensity, the pressure on this infrastructure also increases. The Netherlands is therefore an example of a country where human engineering continuously counteracts natural forces to maintain habitable land. Bangladesh. Bangladesh is located within one of the largest river delta systems in the world, formed by the convergence of the Ganges, Brahmaputra, and Meghna rivers. This geography creates an extensive low-lying floodplain that is constantly shaped by water movement. Each year, the monsoon season brings heavy rainfall across the region. River levels rise significantly, leading to widespread flooding that affects agriculture, transportation, and residential areas. This flooding is not an isolated event, but part of a recurring seasonal cycle. In addition to monsoons, Bangladesh is also exposed to tropical cyclones originating in the Bay of Bengal. These systems can bring strong winds, intense rainfall, and storm surges that push seawater far. Long-term environmental changes, including sea level rise and shifting rainfall patterns, add further pressure to this system. As a result, Bangladesh represents a region where natural water cycles and extreme weather events interact continuously with a very dense population. All of these regions share one thing. They are not random events, they are active systems that can be observed in real time, and this is where modern data becomes important. MeteoVia is a mobile app designed to visualize real-time Earth systems in a structured way. It combines global earthquake tracking, live weather data, and atmospheric monitoring into a single interactive platform. It also includes terrain and altitude maps, allowing users to understand how geography influences environmental conditions. The app is available in 21 languages, making Earth data accessible to users across different regions of the world. In addition, MeteoVia includes a guided assistant that can answer questions related to weather, earthquakes, and outdoor activity safety, helping users interpret environmental conditions in context. Rather than presenting isolated data points, the system is designed to show how Earth's processes are connected across weather, geology, and geography. Back to the video. Indonesia. Indonesia is located along the Pacific Ring of Fire, one of the most geologically active regions on Earth. This zone is defined by the interaction of multiple tectonic plates, including the Indo-Australian, Eurasian, and Pacific plates. These plates are constantly moving, and their interactions generate frequent seismic activity. Earthquakes occur when accumulated stress is released along fault lines beneath the surface. In addition to seismic activity, Indonesia contains more than 100 active volcanoes spread across its islands. These volcanic systems vary in behavior, ranging from slow lava flows to highly explosive eruptions that can affect large areas. The country is also vulnerable to tsunamis, which are often triggered by undersea earthquakes in nearby subduction zones. When tectonic plates shift beneath the ocean floor, large volumes of water can be displaced, generating waves that travel across entire ocean basins. This combination of seismic, volcanic, and oceanic activity makes Indonesia one of the most complex natural hazard environments in the world, where multiple Earth systems operate simultaneously. Philippines. The Philippines is located in a region of high atmospheric and geological activity. It lies within the Western Pacific typhoon belt, where warm ocean temperatures regularly generate typhoons. These systems can develop rapidly and intensify over short periods of time. Once formed, they can produce strong winds, heavy rainfall, and coastal flooding, significantly impacting infrastructure and populated areas. Because the Philippines consists of many islands, storm systems often interact with varied terrain, increasing the risk of landslides and localized flooding during heavy rainfall events. In addition to meteorological risks, the Philippines is also located along tectonic boundaries, which makes it prone to frequent earthquakes. These occur as a result of continuous movement between tectonic plates beneath the region. The country also contains multiple active volcanic systems, adding another layer of geological activity. As a result, the Philippines experiences overlapping environmental systems, atmospheric, seismic, and volcanic, all contributing to a highly dynamic natural environment. Chile. Chile is located along one of the most powerful tectonic boundaries on Earth, where the Nazca Plate is subducted beneath the South American Plate. This process generates continuous seismic activity along the western edge of the continent. One of the most significant events in recorded history occurred in 1960, when Chile experienced a magnitude 9.5 earthquake. This remains the strongest earthquake ever measured using modern instruments. The earthquake triggered a massive tsunami across the Pacific Ocean, affecting coastlines thousands of kilometers away. It also caused significant geological changes along Chile's coastal regions. Due to ongoing tectonic movement, Chile continues to experience frequent earthquakes of varying magnitudes. These events are part of a long-term geological cycle where stress accumulates and is periodically released. The region is therefore considered one of the most seismically active zones in the world, shaped by deep earth processes that operate over geological timescales. The Earth is not stable, it is a system in motion, continually shaped by forces that operate beneath or above our perception, forces that build for years and release in moments. And yet, we build cities, infrastructure, and entire civilizations directly on top of them, often without realizing how active the planet beneath us truly is. If you want to see these systems in real time, you can explore them through tools like MeteoVia, where Earth data becomes something you can actually see, track, and understand. Thanks for watching, and don't forget to subscribe.